Is this science fact or science fiction? Now, look what's happening on the International Space Station. This is no longer science fiction. Yesterday's science fiction is today's science. In our lesson, we're going to use this as a springboard to start talking about the greater world of water and all the environmental impacts.
So we want our kids to understand that the International Space Station is a closed system. And that's not so different from the Earth, because on the Earth we're all traveling on this little planet together around the sun, and there's a finite, there's only a certain amount of resources that we can use. And so we need all to work together to protect and use and reuse our water.
The name of our presentation is Troubled Waters, and I'm Katie Phalen from Tempe High School.
I'm Bridget Samson from Tempe High School.
When we started thinking about what to do our project on, we started looking at all the NASA research on environmental issues, and they're really cutting edge in terms of what's out there for cleaning the environment, working with the environment, and taking care of the environment. We live in the desert in Arizona, and water is a huge and vital resource for us, and a limited resource. As a result, we decided to create this 2 to 3 week lesson centered around water. I will be teaching it to my 9th grade chem physics class in a very limited level. Mainly this is designed for my juniors and seniors who are taking a class called Hope Chemistry, which is considered a health occupations preparatory education chemistry class.
And I'll also be using it for my biology students.
Our mentor is Juan Busto. He is a ground support equipment and integrated systems person at NASA, and he has also been our modeling aficionado. He has helped us create a math model to work into our scenario and help us get that coordinated so that we can talk about environmental issues and show the statistics and talk about efficiency with our water use. This unit focuses on water quality and water reclamation. We have designed a 2.5 week unit, as I talked about earlier, and our plan is to start out with a river water quality simulation, modeling a watershed, and the students will go through that activity. Then they will use that to bring home to an environment in their own community. For Arizona, that'll be the Colorado River Basin, and then we will create mathematical models to talk about efficiency and how to reclaim the most water from a given system. We have a lot of learning objectives that we're going to be talking about in this, that we're going to be dealing with in this unit. Some of them deal with biology, some of them with chemistry, some of them are multi-use. We've highlighted a few of them for you. We're going to be operating the river web simulation. They're going to create a model based on that data. They're going to calculate the effects that making certain improvements at each site in the river web based on what the land is used for will have on the overall system. They're going to design and build their own filtration system, use that same math model to determine the efficiency of their system, compare it against standards for their city, which in our case is the city of Tempe, and then, as an advanced challenge, adapt the filtration system to be used on a space station.
So, we want to wake you up for a second, and we want you to think about how much water do you use every day? And how do you use it? And take like 15 seconds and brainstorm in your head. Don't talk to anyone else. Brainstorm in your head about how much water you use each day and a way that you use it, and be ready to share with each other in like 10 seconds.
Okay, let's hear what you guys have. We'd like to go around the room.
We have to take us off.
I wake up with a morning shower.
Can you hear us?
10
Yep,
15
great.
minutes.
Okay.
You drink about 72 ounces of water a day.
Lots of water used in cleaning and washing clothes and dishes.
Great.
Good one.
So drinking and watering the lawn.
Okay.
Washing my car.
Good.
Good.
All of those.
All All right, so that's a pretty good list. Katie and I think, would both agree that we start our morning with coffee.
Yes.
If we don't, we get a little cranky.
And a little Diet Coke too, maybe a lot.
So we just want to share another short little video with you about what goes into coffee besides maybe just water and coffee grounds. Okay. So we wanted to show that video to our students to help them think about how not just the direct ways that they use water every day, but the indirect ways that they use water as well. Because a lot of them don't have an appreciation for where their water comes from or how water is really a finite resource on our planet. So we're going to start with a simulation with this unit after we kind of do our little engage activity that we just showed you. Here is just a kind of screenshot from the simulation that we're using. It shows a watershed. In case you guys need a review of what a watershed is, it's just a land area where all the precipitation in that area dumps into one river system. Okay, so I'm just going to point out a few things on the simulation for you. We've got there's several different areas in this watershed. There's actually 7 different areas where we can test the water, and there's different indicators that we can use. So there's the level of phosphorus, the level of nitrogen, the level of heavy metals, toxins, and sediments are the 5 indicators that we're using. There's also other indicators that you can look at, including pH, water temperature, dissolved oxygen, and a few others. So what we've got is at the very top, there's a pristine forest, and so they kind of use that as baseline data, and they show that there aren't really any improvements to be made in this area. We've got a section of land that's used for logging. We've got a section of land that's used for residential use. Below that, there's industrial use. Over here, there's an ag field, and then we've got a wetland, an urban area down at the bottom over here, and then finally our last place that we can measure the amount of nutrients and all the other indicators is down at the mouth of the river. So on each of these places in the watershed, you can add one improvement, and the simulation gives you the improvement to add. So your students can compare, for example, we're just showing you a screenshot of the agricultural area. The screenshot is showing you the red line on here is the amount of nitrogen in the water at that agricultural site before the improvement is made. Okay, Then your students can click on this, just this little link up here that tells you about the improvement. The improvement that we're going to make to this ag field is strip cropping. And so when we add that improvement, you'll see the blue line down here shows up. So we've got a double line graph here. And then over here we've got the values before and after, the values of the nitrogen in the water before and after. What we're going to have the students do is use this simulation to create a math model. So they're going to use the before and after values of the indicators in the water to figure out the percent improvement after we implement this improvement to this portion of land. Math people, a way that you might be able to use this is if you take a look, you could have your kids figure out correlation, because you can actually look at two graphs at once. We're just showing you one, but underneath here there's another place where you can look at it. So over on the side is where you change your indicator and change the location where you're looking at, and then you can also change the range, because this graph is a little bit busy. I'm sure you guys noticed that. So over in the day range over here, you can shorten it to whatever you want, like 50 days, 10 days, 100 days, and that makes it a lot easier to see the lines. So math people, you could take a look at maybe the amount of sediment going into the river versus the amount of precipitation, and you'll see that there's a good correlation there. Okay, and then they're going to use this model that they create with the percent efficiency of this implementation, and they're going to apply that to a watershed data that we give them, maybe about the Colorado River, or Katie's going to talk about her next process in her class, which is a filtering system that her kids are going to create.
So the next step in this process, which we would take it in chemistry, we will be taking a field trip down the Colorado River, collecting water samples at different levels, comparing it to our models, seeing where our levels of everything is, trying to figure out what the use would be at those particular areas, given the certain levels, and what we know about what the use should be at each different site. If we could hit the next slide. Oh, do we have it up already? Oops, I apologize, I went too far.
Okay.
On top of that, we are going to have a design challenge in the chemistry classes to build a system that could filter out residential wastewater. We're not going to use a pre-made package. The kids are going to have to come up with their own design. Certainly they will be looking at city water sites to understand what the standards are and what some of the processes are that some of the cities really use. As an engagement activity for that, if we could have a close-up, we are going to run through a scenario of what's going to happen, of what kind of water they use each day. And that's kind of what I brought, and this is something that I think will really catch the kids' attention and make them want to filter it, and also understand how difficult this process really is if we took it to the level that it, its natural conclusion.
It might gross them out a little bit too.
Yeah, exactly,
totally
which they really love. So we're starting our day. And this is my simulated, what's the first thing everyone does? Probably get up and use the restroom. So that's the first thing that goes into our wastewater. Okay, then maybe after that you would brush your teeth, and in doing so you're spitting out toothpaste, and that goes right down into the sewer system. Then you're going to jump in the shower. A couple of you said that, so you've got your body wash, your conditioner, your shampoo. That's also going into our system. If you're a man, you would be shaving, and if you're not very careful and you're doing it in the dark, you may cut yourself, and there'd be a little bit of biohazard going into the system. A little bit of blood. If you're a girl or a guy, you might be putting some hair products into your
Matt, we're talking to you.
Yeah, into the system, because you're going to wash your hands. It's going to go down the drain. Then you're going to go to breakfast. You maybe order some orange juice. You don't finish it, it goes down the drain. You put the rind of an orange that you ate, goes down the drain. Here we come back to our latte. You don't quite finish your coffee. Coffee goes down the drain. It also goes down back to our, in a way, as it's recycled back to our first analysis. Then there's also coffee grinds that many people, when you're washing your coffee pot, go down. I'm assuming everyone's going to be wearing clean clothes, so at some point you would have put some kind of cleanser down. Let's say you're not feeling so good. You maybe take some kind of medicine. Okay, doesn't necessarily have to be Dayquil, and I'm not advertising for Vicks, but you might take some medicine, which will ultimately get into the system. You might put on some sunscreen or bug spray, wash your hands. Eventually that's going to go back into our system. And ultimately, we're going to have something that looks like this, that our students are going to have to build a filtration system to filter out. And as you can see, some of the toothpaste, a little bit of the fizz from the shaving cream, the biohazards indicated in the red, some of the undissolved solids down at the bottom. And this is where the students start their next activity, where they're designing and building their filtration system. We are going to create it as a scenario that they are a city manager and they have to work within budget constraints of a real city. So they have to apply their model to try to get the correct standards and work within financial constraints. They can't have an override election to get a little more money into the system. What they get is what they get. And as I state in the PowerPoint, they're going to use their model from the simulation activity to determine how close their system comes to local standards. As an advanced challenge for some classes, and depending on time constraints of teachers, we would adapt the residential filtration system to work in space, which means they now have to think not only of the financial constraints given a water supply system, but how much it costs to get the system up into space. Are they going to be taking, pounds and pounds and pounds of gravel and charcoal and sand? What are they really going to do that's cost efficient, that can be transported? What's the volume, the weight of their activity, and how do they work around the gravity or lack thereof?
Okay, so we've got quite a few assessments for this little mini unit that we made up. The first thing that's going to happen is students, when they go through the simulation, students are going to jigsaw that activity. So we mentioned that there are 5 indicators. We talked about one of them that was nitrogen. We're going to divide students up into groups, and then one person from each of those groups will get into a different group. So that's the jigsaw part. And so that end group will have an expert from each of the indicator areas. So then they'll talk about and analyze their data and figure out if they only could make 3 improvements, which improvements would they make? So they're going to present that data and analysis to the class as a group presentation. So that's going to be one form of assessment. A second assessment is going to be grading them on how they determine the model that they use, and then also their ability to use that model to find and calculate other values. The third part that we talked about was the filtration part.
Right, and that's going to be graded. That's going to be assessed in a couple different ways. They will have a visual rubric that they will talk about just visually how appealing is the water. If it still looks like this when they run it through their filter, nobody's going to want to drink it. On the other hand, if they have 2 drops of pure water, that's not enough. So they've got to have a good medium, and those are some things that we're going to just say visually. You don't have enough. Yours looks nasty. Yours still smells horrible. Yours may look bad, but it smells good, and I don't see any chunks in it. We're going to have a rubric that assesses that, and then we will be doing testing with water quality kits for near apparatus. A lot of things you can use to test the water depending on what the budget at your school is. So in our lesson plan, we'll give numerous ways to get some actual data that you can compare and plug into the model to see how close you are to what we're trying to get and what your percentage of error is and so forth. And then their authentic research, they're going to have to write up a design plan, and the data they collect, they're going to compare it to what's collected at the waterways, work it back into the whole overarching topic. And maybe we're paired up as a Hope teacher, we're paired up with math teachers, English teachers, and social studies teachers, and we're hoping that this issue can go even further than that and talk about the social impact of clean water on countries that have it, countries that don't, actual wars that are going on because water is such a resource and clean water is such a valuable resource.
So we talked a lot about how this could work in a chemistry class, but I think it's probably obvious to you, or hopefully it is, that you could modify this. I can modify this for my biology class, but you could also modify it for your math class or your earth science class, or, I don't know, Jarvis, maybe your yearbook class. I don't really know how you'd work that in, but maybe you can figure something out. So I think that's it. Do you guys have any questions for us?
And B, what are any of the standards that are associated with this?
I'm going to have Katie speak to the chemistry standards.
We did not include the standards in our PowerPoint. because we had so many. We have math standards, technical standards. It has to do with inquiry, design, graphing, because they are going to be creating graphs. They're not just going to be using the ones on the screen. We have technology ones because they're going to have to learn how to navigate a couple different websites.
I know the biology standard, the Arizona standard is something about human impact on environment, and I know that there is a correlating national standard that's pretty much worded the same way. So,
and what we did, we tied them mainly to our Arizona standards because we kind of came up with the decision that we would be presenting mainly in Arizona, like we're going to be presenting to the Science Teachers Foundation. We designed this because we're also going to be presenting to a sustainability group, which is all business people in the greater metropolitan Phoenix area called Valley Forward, and they have a sustainable, renewable resource night. So we thought this program really tied into the issues that are, very important to Arizona right now. And we're going to be doing it to a couple of other business organizations. So we did tie it into directly to the Arizona standards. And when we get the website up, I unfortunately cannot think of every standard we have now, but we probably have 2 pages worth of standards.
We can show you later, Anna.
Yeah. So.
Thank you.
You're welcome.
Have you thought about how you could also incorporate the hydrological cycle and nature's natural way of filtering water to include that in there, and perhaps include that as a simulation as well?
We have, and we are going to, that's one of the things we're going to be talking about, and it's going to be in our lesson plan. When we go down the Colorado River, we will talk about, what happens at each of those sites and how nature takes, just like you said, how nature takes care of it. And we also realize that not everybody is going to be able to take a river rafting trip down the Colorado, so we're going to try to work it into, swimming pools, ponds, canals, how people can adapt it to what they have available.
But that's a really good point, Rich, because one of the parts of the simulation, there's a wetland area, and wetlands are excellent places for water filtration and cleaning out water. So I'm going to talk about that in my biology class especially, and we're also going to talk about all the biogeochemical cycles. So when we talk about nitrogen and phosphorus levels in water, we'll be talking about how nitrogen and phosphorus cycles through the environment. And
our hope with this program is that Mary Bridget will be using it sophomore year, and then in her biology classes, the kids will have an introduction to it from a biological standpoint. When they get to the chemistry class, they'll run through the simulation again, and we'll take a different path towards more chemical analysis and using the model in that fashion. And it'll be, from year to year, some consistency, and really have them understand that it is an important part of both sciences, and you can't separate them.
Anything else?
Good job.
Okay.
Thank you, Juan, for all your help creating our math lab.